Good evening, sir.
Yeah, good evening.
Sir, speed time graphs are not there for motion, right?
They are,
Okay, sir. But in the textbook, they're not mentioned, right?
yeah, but the concepts are there, so it can come.
Yes, sir. Sir, can you once explain the speed time graph?
Okay,
Sir, my exam is on 8th for science.
okay. So just now I'll be explaining all the graphs. Okay,
Yes, sir.
just I think most of you will be having your exams, so I'll explain them all.
Yes,
Okay,
sir.
first of all, so I'm waiting for everyone to join. Just let everyone join.
Sir, I can post my chemistry doubts also in the group, right? You'll clarify them, right?
Yeah, you can. I think there is already a science doubt group. So anytime during the day, you can post your doubts.
Okay, sir.
Okay. So this is for everyone. Anyone can post their doubts anytime. So considerable. Whenever I find a time, I'll send a solution to it. Okay.
Good evening, sir.
Yeah. Good evening, everyone. So we can start up now. I think almost everyone has joined. Okay. So let's continue. And for today, I will also keep my camera on, and I request everyone to keep their camera on during the class.
Yes, sir.
Okay. So if there is any problem, any issues you are facing, just inform. So today, as few of you are having doubts from motion graph. Okay, so we'll first look up at the graphs. How do the graphs show us, or how do the graphs convey the information? Okay, Pranav, your mic is not working. So is it not working just now only, or it doesn't work permanently? If it's not working for this session only, you can just rejoin the session. Okay, once you rejoin the session, maybe it will start working. Okay, Pranav. So try to rejoin the session. Maybe it will start working. So for this, we'll start now. We have graphical representation of motion. So the quantities which we have studied over here. So in the graphical representation of motion, we study the different quantities like position, time, displacement, speed, velocity, acceleration. So these are the different quantities which we study over there in graphical representation or in motion. These are the things which we have studied. All the changes which we observe or which we study with respect to time. Because everything, whatever we are going to study, that is with respect to time.
Yes, sir.
Okay. Pranav, has your mic started working? You can leave and rejoin and check if it starts working. Okay, Pranav? Or sometimes it happens if you are If before this if you have joined through some other software, like before this Zoom, if you have joined through Google Meet or Teams, okay, so then also it doesn't work. So you may need to restart your computer, then it may start. Anyways, let's continue. So with the graphical representation of motion,
Yes, sir.
see, we have taken here, we represent the motion on the two axes. The two axes we are choosing
So
the
X
axis.
axis.
Okay. So here the vertical axis which I have chosen, that is the y-axis, and this is
Axis
the
and the
horizontal
horizontal is X.
x-axis. You can choose either one, and the x-axis is chosen for representing the time. So we are
Time.
representing time over here on the x-axis, and here necessarily I am representing the position of the object.
Sir, Y can either be distance, displacement, speed, or velocity, right?
Yeah, y can, on this y-axis we either take position, we can take also displacement, we can take distance also, we can
So
take
speed and velocity.
speed and velocity also. So whatever we are observing, for example, if you are observing the change of position with time, so we keep taking position on y and time on x. Okay,
Okay, sir.
so just the two variables we are taking on this. So we take here, let's say for simplicity, we are marking the points here 5, 10, 15, 20, 25, 30. Here we take the time interval to be 1, 2, 3, 4, 5, 6, 7. So we have the two axes ready for the position and time. Let us see what the different aspects can we have. For example, we can have a graph, something like this. This graph is a straight line. So we have a graph over here, which is a straight line. Now, in this straight line graph, what are the things that we observe? You will observe that there are equal displacements in equal intervals of time. See, if you are not able to observe this with one, you can see it's a straight line. Correspondingly, if I want to find out the displacement that it has covered during this 1 second, so from one, I will make a perpendicular, and wherever it cuts the graph, from that point, I drop a perpendicular on the y-axis. Similarly, from the time equal to 2 also, I drop a perpendicular, and where it cuts the graph, from there I draw perpendicular on the y-axis. Okay. So this much is the displacement in the first second. This is the displacement in the second second.
Sir, isn't
So
displacement the area under the graph?
do not get confused with the things. Yeah, just start from, you are starting from the basic fundamental.
Mhm.
Okay. Okay. See what we are going to measure, everything I will be clarifying. So in 1 second, it seems to have completed around 7.5 meters of the displacement.
Yes, sir.
In the next 1 second, it also seems to complete 7.5 meters of the displacement. If you observe the next 1 second, so in the next 1 second also, it seems to have completed about 7.5 meters. So can I say that it is making equal displacements in equal intervals of time?
Yes, sir.
Yes. So whenever you find a straight line in a position time graph, the straight line in a position time graph which is inclined to the x-axis, this graph represents motion in a straight line, and it represents here uniform motion. Can
Okay, sir.
anyone recall me the definition of uniform motion?
Sir, when an object moves in a straight line with constant speed,
Yeah. So when an object moves in a straight line with equal distances in
in equal
equal
intervals of
intervals
time.
of time. This is the definition. So everyone, you can keep your camera on. Just start your camera. I want to see your all of your presence. That's it. And everyone, be active participant during the class. Okay, remain active. Whatever questions are raised. Okay, Pranav, you are having exam. So first of all, don't take a stress about the exam. You are having exam. Just keep your concepts clear and practice a few of the questions. Okay, you'll be able to get it. Will do it after this. This is also from motion now. So here we are representing the displays if it's covering equal displacements in equal intervals of time. So we call it as a uniform motion. As I can see that in every 1 second, it is making a displacement of 7.5 meter, 7.5 meter. Here also 7.5 meter. Here also 7.5. So I can say that it is a motion in a straight line and it is a uniform motion. Okay. Now, okay. So you have this change displacement with time. Yes. Yeah, Ryan. Ryan, what quantity is this? Change of displacement with time. Mohammed Ryan, are you speaking? What quantity we have change of displacement with time?
Oh, it's velocity, right?
Yeah, it is velocity. So see, whenever I am finding out the change of y-axis with respect to the x-axis. So observe the quantity on the y-axis, observe the quantity on the x-axis. So if you have your position or displacement, so change of position or change of displacement with time is called as velocity. So from this graph, if I find out the slope of the graph, see how we'll find out the slope of the graph. The slope of the graph will be equal to the velocity of the object. This is a very important criteria. In every graph, we need to measure the slope. Slope means the inclination of the graph. How much the graph is inclined. So the inclination of the graph will show us whatever the graph is inclined, the inclination of the graph will show us how the uh, what will be the velocity or what will be the change of this y-axis with the x-axis. That we call as the slope. For
Yes.
example, if I have here two graphs, let's say I have a graph A, let me draw another graph here. I have another graph B. So I have another graph B, I have another graph C. So out of these three graphs, which one graph has the highest slope?
Sir, B.
C.
A.
It's
C
C.
has the highest slope.
Honestly.
C has the highest slope. Slope
Yes,
means
sir.
the inclination. C is highest. So which of them will have the highest velocity?
Sir, B.
Why B?
No, sir, sorry. C.
C will have the highest velocity. Harshit, C will have the highest velocity? Yes. So everywhere we find out the slope of the graph and the slope of the graph in this one will give me velocity. As change of displacement with time is velocity. So if I find the slope, it will give me the velocity. Now let us see how do we find out the slope of the graph. To find the slope of the graph, we need here any 2 points on the graph. Any 2 points can be taken. Suppose I just interested with the graph A. So I'm taking only graph A and I want to find out the slope of this graph A. So I will take any 2 points. So suppose I can clearly see this point. Okay. So I can observe this point and this point. With these 2 points, I will find out the slope of the graph. The slope of the graph is given by the formula of rise over run. Remember this slope is given as rise over run. How do we mean by rise over? Rise means how much the graph has risen up divided by how much we have run through the x-axis. So if I take these 2 points, so with these 2 points, I can construct or I can complete here a right angle triangle. Okay. And with this right angle triangle, see, with this right angle triangle, you are finding the rise over run. So see, it's like this. The coordinates of this A or the Y component of A, you can find out the coordinates of this A to be 4, 5, 4, 30. Am I correct?
Yes, sir.
Coordinates of this
Yes,
point.
sir.
And coordinates of this point would be 2,
15,
15,
2.
2, 15. Okay, we are writing x-axis first. Okay. Now, can you tell me what is the rise? How much is the increase in height of the graph?
Sir, it
Sir,
will be
30.
half into base into
30.
height.
No, we are not finding
Sir,
the
it's
area.
30 meter.
30
No.
meters.
Sorry, sir.
Between these
15,
2
15
points,
meter.
15 meters.
15,
See,
one side.
okay, we just want to find how much is the increase in height of the graph. So initially the graph was at 15 and now the graph is at 30. So the rise in graph is 15. Everyone has understood? Shravan?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So how much we have run on the x-axis? How much did we run on the x-axis?
Sir, 2 seconds.
2. So the here we have 2 seconds or 2. And if I find out the slope of the graph, so slope of the graph will be given as rise over run. Rise is 15 divided by 2. This you get as 7.5 meter per 7.5. And since this is a position time graph and change of position with time is velocity, so this must be equal to 7.5 meter per
Meter
second.
per second.
Okay. So the velocity of this graph is 7.5 meter per second. Understood, everyone?
Yes, sir.
Anyone having doubt in calculating the velocity from the
No.
graph?
No, sir, no doubt.
Okay, you can choose any point. Like I can choose even this point. I can even choose the origin. But if I choose the origin to be one of the points, see, if I choose the origin to be one point and this point to be the other point. So find out what will be the, see, what do you get as the velocity again?
Sir, same velocity.
Same
Uniform
again.
velocity.
See, the rise is 15, rise is 15 and run is 2. So again, you get the same velocity. Okay. So at any time, you find out this slope. The slope of the graph will give you the velocity. Everyone has understood this? Okay.
Sir,
Now, yes, Pranav. Yes. Yes. What's the doubt? I think you are muted.
sir,
Try. Yes. Yes, Jitendra.
nothing, sir.
Okay, you are asking something. Then you said, what do you want to ask?
Nothing, sir.
Nothing. Okay. So see, the formula to find out slope will be rise by run. And since this is a straight line, so every 2 point, you can choose any 2 points and you will get the same slope as 7.5. So your velocity will be 7.5 meter per second, which is uniform. Now suppose, again, now I try to make a graph, but now I'm not getting a straight line. Again, I'm taking the similar values. Let's say, okay. So here I'm depicting the motion of some other particle. Let's say again, this is O, 1, 2, 3, sorry. Let's say take here only 5, then 10, 15, 20, 25, 30. So this is again position. Again, we are taking position and time. So position and time. Yeah, Advait, what is your doubt? Advait?
Sir, what is run here? Run.
Run means how much you are moving through the x-axis. Run simply
Okay.
means here you run through the x-axis. So during this portion, how much is the increase in the height of graph? That is what. Okay.
Okay, sir.
Okay, Advait, what is the meaning of your name?
Sir, mediator.
Advait means mediator.
Yes, sir.
No,
Yes, sir.
it is a very deep meaning. Just find for it. Okay, find it. What does Advait mean? It is a very deep meaning. It's not mediator. Okay, see here. I'll tell you later about Advait. So now suppose I have a graph like this. The graph is going something like this. So can I say that the graph is a linear graph?
Yes. There is a
Is the
non-uniform motion, no?
is the graph linear? Do we have a straight line?
No, sir, it's non-uniform.
Yeah, it is a non-uniform motion. Since the graph is a non-linear graph, we have a non-linear graph. So a non-linear graph means the object has non-uniform motion. But remember, this is we are only discussing with respect to position time graph. Everywhere we are discussing with position time graph. So when we are talking position time, you can also assume it to be the displacement time also. Okay. But do not go about the velocity time. This is just position time. So a non-linear graph will mean a non-uniform motion. And here, as I can see, the displacement in every interval of time is not the same. For example, the displacement that it has made in 1 second. See, if I make in 1 second, I draw the graph over here. It cuts the y-axis at this point, which is even about 2. The displacement in the next 1 second is still less. The displacement in the next 1 second is a little bit more. The displacement in the next 1 second is still more. So here the object is not traveling equal distances in equal interval of time. Is it traveling equal displacements? See, in the first second, it has traveled a displacement about 2. In the next 1 second, it has traveled a very small displacement. In next 1 second, a little bit more displacement. So on, your these displacements are different, and hence this motion is a non-uniform. Got it, everyone? So from this one, if you are given any 2 points, suppose if you take any 2 points and find out velocity from that using rise over run, so here you will be getting average velocity. You will be getting the average velocity and not the actual velocity. Got it?
Yes.
So this is just the average velocity which we get as displacement by time or position over time. So these two graphs, they are possible. Now let us see some doubts with speed time graph or distance time graph. So let us try to construct a distance time graph also. So let's say this is the distance. Now we are representing on the y-axis. I'm taking distance as t, and here we are representing time. So see, I will be taking here a few examples. Suppose again, I have a straight line like this. I have a graph, something like this. Let's say I have a graph like this. I have another graph, something like this. Okay. So, what do these three graphs represent? what does the graph A represent here?
Sir,
Yes.
graph A represents uniform
Speed of the
speed,
object.
constant speed.
Okay.
Sir, the object is in constant speed.
Increasing speed of an object.
Yes, sir. Sir, acceleration.
No, it's not representing. How will there be acceleration if it is having a uniform motion? It is
Sir,
a
it's
straight line.
constant speed. Sir, then
Yeah,
it's
it is a
constant.
constant speed. Okay. Since the graph is a straight line, it is a constant speed. So there is no change of speed. It will be traveling equal distances in equal intervals of time. So this is a uniform motion. Got it? Graph A represents uniform motion. What about the blue line?
Sir, it's rest because it's on zero.
It is in rest, sir.
Okay, B is in rest as we are not observing any change of distance with time. So B observes it to be rest. If you have this line C, so what does the line C represent?
Sir, nothing, sir.
Nothing?
No, sir, one second. Sir, it's retardation, right?
No. Okay.
Sir,
See what does
this doesn't represent anything because it's not joined from anywhere. This
okay,
line.
even if it's not joined, if I observe at this time from where it starts, so at this time it marks a point on the distance. So this is the distance where it was or the distance traveled by it at this
Okay.
time. Let this be time t1. Okay. At the next time when it ends, so this is your the graph cuts over here, and accordingly on the y-axis, this is the second point. So let this be the point S1 and S2. Now, initially, it had traveled the distance S1 and finally it has traveled the distance S2. So, which one of them is greater? Out of S1 and S2, which one
S1.
is greater? S1 is greater. S1 is the distance of the first at time t1 and S2 is the distance at time t2. So, is it possible that distance will decrease with time?
No, sir.
No. Up to now, whatever examples we have done, we have seen that distance cannot decrease with time. At least it will remain the same or it will increase, but it cannot decrease with time, even if you return from that place. Suppose you start from some position, travel here 4 units, then again return back. So your displacement or your distance will not become zero. Your distance will become double of it. Displacement doesn't become less, it doesn't become negative. So this graph BC is the graph C. It represents that the distance is decreasing since it is not possible. So can I say the graph BC is not possible?
Yes.
Yes. The graph C is not possible. It can't happen. Okay. Now is the same graph possible in this position time graph? Suppose here I make some line like this. I make somewhere here. So is it possible to have a graph over here? Let's say this is our graph C. So is it possible to have a graph C like this in position time graph? Yeah, is it possible?
Certainly.
Okay. See, we on the y-axis we have taken position. Okay. So can it happen that position decrease with time?
No.
Anyone? Yes.
Yes, sir.
It is yes. It is possible that that position can decrease with time. Suppose it's a number. Suppose this is our x-axis, and we start walking on this. Suppose we start walking from this origin. We go to this point 1, 2, 3, 4. Suppose we start working like this. We start with, we from O we go to 1, then we go to 2, then we go to 3. Again we come to 2. So do I have position decreasing? Yes, I have position decreasing. So here, since position decreases, therefore I will say that yes, this graph is possible. The same thing in the position time graph, the same graph is possible. But in the distance time graph, the same graph is not possible. Got it? Understood, everyone?
Yes, sir.
Okay. Anyone who has not understood? Sampath? Yukta?
Sir, I understood.
Okay. Okay, what about this? Okay, what does it represent then? A graph downward, in the downward direction. If you have in the position time graph, if
Sir,
you have a,
retardation.
no, see, till you have a straight line in the position time graph, your acceleration will be 0. So you don't need to think about acceleration and retardation. Acceleration and retardation will be there when you have a non-linear graph like this. So here, in this graph, if you have a graph moving downward, so such a graph represent negative velocity. See, initially the displacement was 25, then the displacement become 5. So if you observe that displacement during this position, the displacement during this position will be final position minus initial position, which will be 5 minus 25, that is negative 20. Okay. So if you find out velocity here, the velocity will be negative 20 over 2. Has the graph risen or has the graph fallen? What has happened in this?
Fallen.
Jitendra, has the graph risen up or has it fallen down?
Fallen down, sir.
It's fallen down. So rise will be positive or negative?
Negative.
Yes, here we will be having a negative rise. So velocity will be negative. If you have in a position time graph, if you have a straight line moving upward, it represents a positive uniform motion. If you have a straight line moving downward, it represents a negative uniform motion. Okay. If you have a straight line parallel to time axis, it means zero velocity. Okay. But if you are having a distance time, so for the distance time, the scene changes. For the distance time, no downward graph is possible. Even if you have a graph like this, so such a graph is also not possible. Okay. A graph like this is also not possible, as it is also moving downward. Whereas if you have a graph something like this, it is possible. So understood about the position time and distance time graphs, what is possible and what is not possible. Okay,
Yes,
so
sir.
from this distance time graph, what can we calculate? If I find out the slope of the distance time graph, so what will I get? Okay, what will be the slope of the graph? Yeah, slope means the change of y-axis with x-axis. And on the y-axis, we have taken distance. So slope will be change of distance with time. And change of distance with time is called speed. So if I find out slope in this graph, I will be obtaining speed. If I find out slope in the position time graph or displacement time graph, I'll be obtaining velocity. Got it, everyone?
Yes, sir.
Okay. So in this, these are the two graphs. Now we'll be starting with velocity time graph. Now, if just have a look at all the graphs and things that we can measure from them, what we conclude from their graph. Okay. All these are distance time graphs. The next, now we start with velocity time graph. So do not try to apply
Sir,
all these things. Yes.
sir, in the first chapter, until where did we complete? Actually, I was absent.
When did we complete?
Until where?
Yeah. So first chapter, I think we completed in the month of April and May.
Sir, second chapter, force. I was present
Second.
until the first law of motion.
Okay. So just a few days back only, I think we have completed. And we need to do still some questions from that. So it's not complete. That means the theoretical part has been completed. We need to do some questions from third law of motion and conservation of momentum. We
Okay, sir.
just have initiated with the conservation of momentum and third law, right? So now we take here velocity time graph. So do not apply the logic which we had studied in the position time graph. The logic here will be again different. If you plot a velocity time graph, so it shows how the velocity is changing with time. It represents how velocity changes with time. So here on the y-axis, we plot velocity, and on the x-axis, we plot here time. Right? So this is the origin O, or we mark it as 0. And we can see again if we take the same values. So this is 1, 2, 3, 4, 5, 6, 7. So all these I have taken time in second. Suppose here I take again 5. The values are same: 5, 10, 15, 20, 25, and 30, 35, let's say. So now these values, they are not distances. They are velocities in meter per second. So this represents velocity in meter per second. Now it does not represent distance or displacement. So the graph seen is changed now. Again, even if the graph, the shapes of the graph would be the same, but the inferences will change. For example, suppose if you have a straight line like this, suppose if you have a straight line like this, or let's say like this is a straight line graph that we have drawn. You can have a straight line graph, something like this also. You can have a straight line graph moving downward also. Let's say here I make a straight line moving downward. You can also have, with the non-uniforms, you will be having the uneven graphs. Okay. Now see, the inference will change. Try to understand each and every point. So let me mark this point as A, B, C. Okay. So what does the graph A indicate?
Yes, sir.
Sir,
What does
here
the
is
graph?
uniform
Yes, sir.
acceleration.
Uniform acceleration. Where is acceleration then? Okay,
Sir, can
just
you
Sir,
check.
repeat?
uniform velocity.
Uniform velocity. How uniform velocity?
Sir, the same velocity goes on until 5 seconds.
Okay.
So the
Sampal.
velocity is same.
Yeah. Okay. Sampal.
Yes, sir.
Okay. What does the
So,
graph A
it
represent?
will be zero acceleration. Will it be zero?
Sir, the
Yes.
acceleration is zero as the velocity is constant for whole time.
Okay. So is the object moving or stationary?
Sir,
Moving,
moving.
sir.
Sir, it's moving.
It's moving. So the graph A, it represents uniform velocity, and the object has a uniform velocity of 25 meter per second. You can say it has a uniform velocity of 25 meter per second. Got it? Since at the time 0, the velocity is 0, so it has uniform velocity of 25 meter per second. At 1, at time equal to 1 second, still the velocity is 25. At time equal to 2, still the velocity is 25. At time equal to 3, still the velocity is 25. So at every interval or at every moment, the velocity remains the same. So it means that it is traveling with a constant velocity, and whenever anything moves with a constant velocity, we have acceleration equals to 0. Now the same information, if you had a similar graph in the position time axis, the information was different. In the position time, if you have a straight line parallel to the time axis, it means the object is stationary. But for this, you are having a graph parallel to the time axis. So it shows that it is moving with a constant velocity. It doesn't show the graph to be stationary. Okay.
Yes, sir.
Okay. What about this graph B?
Sir, uniform acceleration.
Okay. So as per graph B, it indicates that velocity of the object is changing. It indicates that velocity is changing continuously, but it changes at a constant rate. The change of velocity is at a constant rate. So here velocity is changing, but the change of velocity is constant. See, in the amount of increase of velocity in every 2 seconds is the same. Or in every second, if you observe, the amount of increase of velocity is same. But yes, the velocity is increasing. Can I say that velocity is increasing? Yes or no? Can I say velocity is increasing here? See, at this point,
Yes,
when the
sir.
time when the time is 1 second, when the time is 1 second, the velocity is about 3 meter per second. When the time is 2 second, the velocity is about 6 meter per second. I'm just using approximately it is, okay. When the time is 3 second, the velocity is approximately 9. So we observe that the velocity is changing with time. If you have a changing velocity with time, when the velocity changes with time at a constant rate or by an equal amount, we say when the velocity changes with an equal amount, we say that it has a uniform acceleration. So for the graph B, it represents uniform acceleration. Okay, if you are not feeling interested, you are feeling bored, so just inform me.
Okay, sir.
Anyone who is feeling bored?
No, sir.
See, either it will happen that you know everything, or it is that you are not just interested, you are not getting what we are doing. So this should not be the same. Participate, ask your doubts.
Yes.
Okay. When I made my camera off, everyone made his camera off. But when I got my camera on, no one makes the camera on. So this represents a uniform acceleration. What type of acceleration is it? Is it a positive acceleration or a negative acceleration?
Positive acceleration.
Positive acceleration. Okay. So it is a positive acceleration. And here, if I find out the slope of the graph, so the slope of the graph will be again given by the same formula, rise by run. Okay. But what quantity will I get if I find out here slope of the graph?
Sir, acceleration.
Yeah, Sharwan? Shravan,
Yes, sir.
what quantity will we get? if I find out here the slope of the graph?
Zero.
Okay. No, what quantity will I get if I find out the slope of any of the graph? That means, will I get displacement? Will I get velocity? Acceleration. Very good. So we'll be getting here acceleration. If we find out the slope of the graph, we'll be getting acceleration. So again, to find out the slope, we will use the same concept. You can take any 2 points on this graph. So on this graph, choose any 2 points. Let's say I choose this point, I choose this point. So any 2 points are chosen, and you find a rise over run. You can take any point in between also. You find out rise over run, and that will be your acceleration. What about this graph C?
Sir, negative acceleration.
Yes, very good. Graph C represents a negative acceleration. So which graph we are studying here?
Velocity
Which,
time graph.
yeah, we are studying here velocity time graph. What changes in the graph do you expect if I draw a speed time graph? Suppose if I had a speed time graph and I draw all the three lines. I draw A, I draw B, I draw C. So what about C? What can we say about C if I take a speed time graph? Is it possible that in the speed time graph you have a negative slope graph? Yes or no? Okay. Can the speed decrease with time?
Yes, sir.
Yes. So what does the graph C is representing? It is representing the decrease of velocity with time. So if you make a velocity speed time graph, so graph C will represent a decrease of speed with time. So it is possible. If you make it a velocity time, if you make a speed time graph, so even graph C is possible. Okay. All these graphs are possible. Just one more example. What if I take a non-linear graph, something like this? A non-linear graph, something like this. So what do we expect from this graph?
Sir, non-uniform.
Yeah. So this graph makes or it shows non-uniform motion or non-uniform acceleration. Motion is still the uniform. The graph B also represents a non-uniform motion. Okay. But the last graph represents non-uniform acceleration. Here acceleration is also not uniform. It is also non-uniform. Okay. Now the last point where we expect questions from this graph. Okay. The questions which are expected from the velocity time graph. See, the slope means
Yes,
the change of velocity with time. Okay. If you find out the area under any graph, area under any of the velocity time graph, so what quantity we obtained?
yes, sir.
What quantity will be obtained if I take a velocity time graph? Okay, let's see here again. So you have velocity, here you have time. 0, you have 5, 10, 15, 20. Let's say again you have 1, 2, 3, 4, 5. fix. Now for this, let's say for an example, I have taken any graph. I find out this graph. So what if I find out the area under the graph? Okay, what would the area under the graph be given by the formula? What formula will be there for this area under the graph? Yeah, Sampath, Mohammad Rayan.
Yes, sir.
Yeah, Rayan. What quantity will I get if I find out the area under the graph?
Can you repeat?
Okay. See, if I find out the
No, the
area under,
question, I didn't hear you.
okay. So what will be the area under this graph OA?
It will be the distance.
Not distance, we will call it as the displacement.
Okay, yes, displacement.
Since it is a velocity time graph, so area under the graph. So area under graph would represent displacement. So whatever figure we get over here, we apply the formula accordingly. Accordingly, we apply the formula and hence we obtain the displacement. We can obtain the displacement by finding the area of the graph. For example, for this case, you are getting a triangle. Okay. And in this triangle, the area of the triangle will be given by the formula half multiply base multiply height. So definitely the area will be 1 by 2 multiply base multiply height, which will be equal to the displacement of the object. Anyone facing any problems?
No, sir.
No, sir.
Okay. So currently I can see Sampath, Sarvan. Okay. Okay, students. So I will try out a few questions from these graphs and then we can move. We'll end up. Just wait for 1 minute. I'm sending some questions in the group also. I'll upload the question here also within a minute. Mm. Okay, so wait for just 1 to 2 minutes. I'll be getting the questions for this. बन गया है. Okay. So I'm just sharing the screen again. Okay. So from the list below, choose the term that best completes each sentence. For the first one, an object is in dash when its
Motion when
distance
its
from A,
distance
you
from a
have the
reference point is changing.
so you have these options. Option is motion,
Sir,
velocity.
first one is motion and reference point.
Yes. So for the first one, you'll be getting here an object is in motion when its distance from a reference point is changing. So that is your first one. Speed in a given direction is called
Velocity.
Velocity.
this will be velocity. And third one.
Speed.
Okay. Now for question 4, see which of the following graph shows runners moving at the same speed?
Sir, B.
D, sir.
Sorry, sir. D.
Yeah. The graph D shows runners moving with the same speed. As these are distance time graph, and in the distance time graph, slope gives the speed. So
Yes,
those
sir.
graphs which will have the same speed, they will same slope will be the same speed. For question 5, which graph below shows that one of the runners started 10 yards further ahead of the other?
Sir, is
A,
it
sir.
C?
Which ones? Yes.
C.
A, sir.
Which one started? It says that one of them started 10 yards before.
Sir, so A.
Yeah, it is A.
A, sir.
At the starting point only, one of the graph is ahead of the other by 10 units in the distance.
Yes, sir.
So it is graph A. Then match the description below with graph. Be sure to explain your answer.
Sir, A is the car is traveling at a constant speed because in a
Cars,
distance line graph, a straight line shows constant speed.
okay.
Sir, B shows the speed of the car is coming back.
The car is coming back, or does it show? You have the options here. Out of the given descriptions, here are the descriptions. Okay. So which of the description will describe A? Which
Sir,
description will
the car
describe
is traveling at a constant speed because it's a straight line. And in a distance time
standing
graph, straight line
for
means it's
A?
a constant speed.
Okay, for the graph A, which one shoots?
Sir, one.
One.
Two.
No. For the graph A, it is one. Okay, for the graph A,
No,
it is
sir.
it is
For
two.
graph
The
A, it's
car is
two.
traveling at a constant speed.
Yes, sir. Graph A is two.
Okay. And for graph B,
Sir, 3.
Sir, graph B, the car
Sir,
is
3,
coming
sir.
back.
yeah, it is 3. The speed of the car is decreasing.
Oh,
And for
decreasing.
graph C,
Sir, the car is stopped because it's non-uniform motion. It's not at
no.
motion. It's at rest.
Yeah, it is at rest. The distance is not changing with time.
Sir, then the graph D is the car is coming back.
Graph D,
Sir, D is the car is coming back.
no.
Yes, sir, because that's the only option. I think for B, it's the car is coming back, and D shows the car
Okay. D,
speed
you
is
can say the
decreasing.
car is coming back. Okay.
So D is the car speed of the car is decreasing, right?
D says the speed of car is decreasing.
Yes, sir, that's all.
Okay. Okay. So D says the speed of the car is decreasing.
And B
All right.
shows the car is coming back. Yes, sir.
Okay. So bye all of you. We'll see again in
Thank you,
next
sir. Bye,
class.
sir.
Okay. Bye.